All right, so here we are. We've got section 10.4. This is exceptions to the octet rule. Um, and this is going to be kind of brief, but there are exceptions to the octet rule. Not every single atom not every single element on the periodic table has to have those 8 electrons around it. We've already seen that with hydrogen. Hydrogen has the duet rule. When it forms a bond, it wants to see 2 electrons. It doesn't need to see 8. Okay, so less than an octet. As we said, hydrogen, or as I said, hydrogen forms a duet, not an octet. There are other very small atoms that also form molecules with less than an octet. Your examples for those are beryllium with the symbol Be and boron with the symbol B. Beryllium has 4 electrons in its valence shell, and boron generally is going to have 6 valence electrons in its valence shell. One common example that people like to throw out is boron trifluoride, BF3, and what that looks like is this. F, doot, 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 and finally the last one, F. Now, um, if you looked at this on the periodic table, you'd say, okay, boron's rolling in with 3 electrons, each fluorine's rolling in with 7 electrons, so add those up, that's 24 electrons, and well, this has 24 electrons drawn, so this is one of those instances where you're going to have to commit to memory that boron does not have to have 8 electrons around it. And that molecule that you drew with, well, 24 electrons, and only 3 bonds coming off of boron. That is correct. It might seem a little bit odd when you've been drawing and following the octet rule, but this is just fine. Now, where it gets a little bit hairier is whenever you exceed the octet. So if a central element in a molecule or a polyatomic ion is in the 3rd period or beyond, so remember periods are the rows going left to right, it can sometimes expand its valence shell. So 3rd period. So if you think about the periodic table and what's in the 2nd period, for instance, the 2nd period has nitrogen and oxygen, carbon. It's pretty rare that you're going to find something there that exceeds its octet. However, below that, where you'll find things like sulfur and phosphorus, those can exceed and expand their valence shell beyond 8 electrons. So they go beyond that 8 electrons surrounding it. Now, central atoms with expanded valence shells are also known as expanded octets. They can share more than 4 pairs of electrons. Expanded octets result in lower formal charge in most cases. So to illustrate that, we've got this right here. This is a molecule SeO3, selenium trioxide. Now, selenium is beyond period 3 on the periodic table, and so it can exceed its octet. Now, when you draw this structure right here, following the octet rule, well, you've drawn it correct, but you've also drawn it incorrect. And this kind of harkens back to what we talked about in the last section where we were talking about formal charges. And if you draw the molecule like this, where I've drawn this other star, well, or not star, scribbled a little bit, you'll see that, well, every single one of the atoms in that molecule has a 0 formal charge, compared to that which follows the octet rule, where you've got 3 atoms within that molecule that have formal charges. Now the net of that formal charge is still 0, but this expanded octet is better. This is an instance where you can expand the octet, so you should expand it. So this isn't a completely frequent thing, but the better you are at calculating formal charges, the faster you can do it, and therefore the faster that you can kind of verify or validate a structure. Now, I wanted to go ahead and show you all an example of a molecule that can expand the octet. Our central atom in chlorine pentafluoride is Cl. Cl is bringing in 7 electrons. There are a total of 5 fluorines, and each fluorine is bringing in 7 valence electrons. So we're talking about a total of 42 electrons. Now, the key of this is to first identify your central element, which is Cl. And then what we want to do, we've got our sum of our 42 electrons. And we're going to draw this right here. F, 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 and F. Okay, now drawing it just like this, chlorine has already exceeded its octet, but based on chlorine being below, or period 3 or beyond, well, it's just fine. Now, how many electrons have I drawn here? I've drawn 10. I'm going to go ahead and do the rest of these. Now I'm at 16. That will be 22. 28. 34. 40. So I've drawn 40 electrons. Am I running into a little bit of a problem? Yeah, I have. For instance, the problem that I've run into is I have 42 electrons to place, and I've only placed 40 of them, so I have 2 kind of delinquent electrons. Now the question is, one option would be I throw those electrons onto a fluorine. Another option is I put them on my central chlorine. Okay, now keep in mind, this goes back to placement on the periodic table. Fluorine is in period number 2. So can it exceed its octet? It's much less likely to than something like chlorine. So what I'm going to do is I'm going to put these 2 additional electrons on chlorine. Chlorine's exceeded its octet. We're good to go. I've drawn my 42 electrons, and that's all there is to it. Now this right here is a little bit of a summary of all of the kind of a Cliff's Notes of exceeding the octet, and basically your summary of the octet and when it applies and when it doesn't apply. Now, this bulk at the top, we've already kind of talked about it. And we've talked about it in the form of the duet rule as well as the octet rule. Everything below that, well, those are going to be your exceptions. So I'll bring you down to this, period 3 elements and beyond as the central atom, or period 3 elements and beyond as an outer atom. Essentially, your mechanism to check this and to kind of reconcile this is to use formal charges and be able to calculate formal charges. Period 3 elements and beyond as the central atom, they might have at least 8 electrons with some exceptions, but they can accommodate more than 8 electrons. We saw that with that selenium trioxide. You could draw that molecule with the octet rule in effect, but we found that when we expanded our octet, or expanded our valence shell, it got better. It got better in that we reduced and eliminated charges. All right, well, I would say your takeaway from this is follow the octet rule, but be ready to calculate formal charges, and if something is in period 3 or beyond, well, then it can exceed that octet. I hope this is helpful, and I'll see you in the next section.